Okay, modeling thick finishes. Thicker finish materials such as tiles, stone pavers, or terrazzo can be applied as unique floor types and modeled where required. For large areas of finish, such as a public atrium or airport terminal, you can assign these materials within the layers of a floor assembly, and we'll do that first. When you need to add small areas of thick floor finishes, you may encounter one of two scenarios, with a depressed floor and without. In areas such as bathrooms, a thick-set tile floor may require the structural slab to be depressed in order to accommodate the thickness of the finished material. The main floor object in this figure that I'm about to do is going to be cut with an opening at the inside face of the walls. Another floor is modeled with a negative offset value to accommodate the thickness of the tile material. And the tile has been placed as a unique floor element. Now, there's various ways to do this. If you do not need a finish, but just a slab depression, you can create it with an in-place void extrusion. Select the architectural tab in the ribbon and click Component Model in Place. Choose the Floors category and create a void extrusion where you need a slab depression. Remember to use the Cut Geometry tool to cut the void from the floor before finishing the family. All right, so let's just do that. Let's just make sure we have this all set up so we can see it in our views. We have a section, longitudinal section. Let's draw another section view right over here. Let's drag the back plane, far cutting plane, a little closer, right there. All right, so it says we can create an in-place floor depression. Architecture, model in place, floor, right? So we can get into the family editor. Let's just let's leave this as floors, floor depression, floor DEP -1, floor depression 1. How about 1.1? There's multiple floor depressions on the first floor, so we have a name for them. Anyway, so floor 1.1. We're just going to create an extrusion, or we can create a void space, right? We can create a void space if we wanted to. Let me cancel that. We can create a void space, and it'll cut it automatically, right? It should cut it automatically. It says you have to actually select the geometry cut tool, but I remember earlier in the chapters it says it'll cut it automatically. Let's put that to the test. So floors, let's just call floors 1 for now because I'm running out of time. A void form, a void extrusion. Now, give it a negative, right? It says a negative depth. So let's start with a rectangle. Now let's just drag it about that big. And we can actually assign this a negative depth. Well, right now, it starts at 0 and it goes up to 1 foot, and it's a void. So it's going to cut the whole slab out if I was to hit that. So let's just make this. Let's make this 3 inches. Okay, let's test it this way first. Now, I want to get this section open because you're going to see, right, some void forms of this filling do not cut anything and will be deleted. To make a void form cut something else, use the Cut Geometry tool. Well, there's a reason, because the void form isn't down deep enough. -3 inches, right? -3 inches is where it's going to start down from the level. Let's give it an extrusion end of 3. So it'll bring it up flush to the underside of the floor, and this should cut it. Some void forms, if they do not cut anything, will be deleted. To make a void form cut something else, use the Cut Geometry tool. Well, it's not letting us. So cut the Geometry tool. Cut. Select geometry to be cut. Well, the floor. Select void geometry to cut out. Select void geometry to cut selected solid. Okay. Now let's see if it cuts it. Okay. So you have to actually cut. It won't cut it automatically. Now let's take a look at that section. and see if indeed we have to adjust any variables. Let's go to View, and you see on level 1, well, there it is. It's a floor, right? It doesn't say that it's a void, so you're going to have to look at it. Come over here. Let's zoom this model around. Let's zoom in and see indeed it is a void. If I tab, I'm going to get out of there, and if I tab around and select just that, it's considered a floor, and but you can't tell that it's void. The only reason you can see that it's void is because it cuts it out. Now, that's one way of doing it. If I reiterate that, that's modeling in place, choosing the floor category and creating a void extrusion where you need a slab depression. Just remember that you don't give it a depth, a negative depth, give it a level start of negative, offset from level, positive or negative, and then give it a depth. So if you let's say if you offsetted it from level +1 and gave it a depth of -6, that may work. Or if you offsetted it -3 from the level and then gave it a thickness of 3 in the positive direction, you'll get it cut to the underside of to the flush top of the slab. Now, technically, if you brought it 3 inches down and created the extrusion 12 inches up, you would still get that effect. You would have 3 inches cut from the top of the deck, from the cut plane 3 inches below the level, and then you would have 3 inches cut and then an 8-inch void space above that, which would cut anything else that was in its place. But this particular floor slab doesn't have anything above 3 inches, right? All right, if that makes sense to you. Now, the other way is as an alternative. You can create a floor-based generic family that contains a parametric void extrusion. You can download this file, slab depression, as an example of this type of family from the book's webpage. Now, I did that, but I undid the whole entire exercise because I wanted to show you how I did it. So I'm going to see if it's still in here, is loaded in, because it comes in as a generic model. And it's not. The only generic model is Corbu. And I did look up the word. I suggest you do the same. That's the man, Corbu. So the generic model isn't in yet. So we can just go to Insert, Load Family, and you see in the Chapter 14 directory, there's an RFA called Slab Depression. And you see, just by looking at it, it's a rectangle and has some parameters to it, some dimension parameters. And you're going to see them pop up. I don't need to open it for you to see it. You'll see it. We talked about that, flexing the model. Well, there it is. It came in under generic model, slab depression. So if I go to level 1, and I go by Corbu over here, and I take slab depression, I drag it in, I'm going to get this witness line, or these dynamic dimension variable lines, dynamic snap tracking, if you will. And I'm just going to place it next to Corbu, and I'm going to drag it down, and it just stops. It's inserted, and as you can see in the properties palette, it's just there's the slab depression. If you look under, it comes in under where the furniture and some of the other generic models are in place, landscaping. Just so happens to be built that way as a family. The family category is important. The family category is important because that's where it's going to place it within the family hierarchy. And if it's the wrong category trying to go in from a discipline that you're inserting, you get an error message, wrong family. So it's pain, but you have to create your families, and when you get to that in the next chapter, you have to create your families with these parameters, or they'll be a bit off kilter. All right, so we have this this nice slab depression, and it's still in the command. Let's pick on it and take a look at the parameters that were programmed into it. Length Y, length X, and cut depth, which is great, right? So we have an X, a Y, and a depth. Right now it's cut at 3 inches. Let's just drag it bigger here. We have grips, so you can drag it over. Let's bring it to, look at the bottom elevation. If I drag it to Kobu's left foot, now he runs the risk of falling into this open little, God forbid, if it was a shaft, he runs the risk of tripping. And if it was a shaft, we'd have to put you have to put up a fence around here, as per OSHA, and put tape and make it highly visible and make it so that no one can lean against it. It has to be OSHA compliant. Even in the event that you depress a slab, it should be painted a little bit for safety purposes. You don't want to trip. Anyway, speaking of tripping, let's not go off on a tangent, transient, a spike. Let's stick with the program. All right, so that's the other way. And then you can build it into the assembly of the floor, right? Finally, if the structural requirements allow a thick finish to be applied to a floor without dropping the structural slab, a finished floor element can be modeled directly in place within the structural tab. Actually, that's another way of doing it. We could just model another floor right into it, right? I mean, there's nothing saying we can't just go to architecture, go to floor architecture, create a rectangle, and just come down here and draw a rectangle and call it a lightweight, call it slab on grade. We can call it whatever we want, right? It's slab on grade, or we can call it, what other kind of a generic 12. We can duplicate the type, right? We duplicate the type, call it a 3-inch depression, 3-inch, just call it 3-inch, 3-inch tile set. Hit OK. Now its default thickness is 1 foot, because if you look, the structure, let's turn this to finish, let's go this to 3 inches. Let's just give this a material category of terrazzo. And hit OK. Hit OK. Hit OK. And then let's see, I think we should be all right. How the floors overlap, well, we're going to know that, right? Well, there it is. It's built within the floor without changing the structure of this floor, which we'll do now. There's absolutely nothing, there's no reason why. We do that here on the first floor. There's absolutely no reason why we can't come into this floor slab. It's regular slab on grade. If we were to look at its properties, its assembly, its structure, cast in place concrete. Well, we could go to structure, insert a layer, change this layer to finish 2 with a cut hierarchy of 5, if you remember the cut hierarchies. 5 won't cut through anything. And then just give this a material. And give it a, what do we got here? Not much. We can make it wood. We can make it wood veneer, wood flooring, maybe. Let's go with some wood flooring just for ha-has. Hit OK. Hit OK. Every 2 must have a thickness we didn't give it. Let's give this 3/4 of an inch, 0.75. 3/4 of an inch, and hit OK. Hit apply. Hit OK. And as you can see, in this, on the first floor, if we go to Fine, and we turn off the shading, let's go to Hidden Line. Slab edge. Well, if you look at this, hold on. So all that glitters is not gold. There it is. Looking at it the wrong view. Floors only. All right. So as you can see, there's the extra layer on the first floor. Now, if you look at this in 3D, you'll see why this looks like this. If we look at this in 3D, you can get a better idea of why it has that odd shape, because we put in it. If you remember, we on the first floor, we put in that profile, right? We put in that profile that keyed out just this section, right, of the slab edge. So that's why we're getting this this look, and we're not getting it in section, right? We're not getting it in section. All right, so I'm just going to hold that thought for a second. This view has its parameters pretty well set. Floor is only 3D view. I'm pretty comfortable with that, and that's pretty much it now. We can cut the geometry out as well, to actually cut it out, put in a mass in place, and create any shape you want, and just cut it out. Now, this shaft opening tool. We're going to get into this, but this also is a tool that you could use, and it's going to go into it more in depth soon. But this is good for shafts because the shafts will move on all the levels if the shaft moves, and it's good for any raceway, any type of raceway, piping, conduit, mechanical piping, ductwork, plenums, anything. We'll get to that tool. Anyway, I wanted to stop it there. This is just thick, allowing thick finishes, and where it's more than just a skim coat, if there's maybe a topping slab. And we still haven't gotten into pitching these, obviously for drainage purposes, right? Floors aren't always flat in the X, on the X plane. If looking at it in elevation, right? In elevation, sometimes there'll be a pitch. There may be a pitch, like in a shower, right? Or any draining floor, whether it's a drain. And the whole floor doesn't have to be pitched in one direction. On one floor, you can have multiple areas or multiple perimeters that pitch different ways. Just like a roof, right? Just like a roof. The object is just to get the water out using gravity. And in some instances, these floors will pitch up, right? Ramps, and again, there's a ramp tool, as you see, circulation. But there's also, could be reasons why you want to pitch a floor up. And we'll get to that. But I think that's a good enough segue into ceilings. We still have a lot more to get to. Because we're going to put all this stuff together, understanding advanced modeling methods, advanced shape editing with floors and all of these things. Just like we went into creating complex wall systems. And then we're going to tie it all together. And then we have to start documenting it, right? And then we have to start getting it on paper, annotating it, documenting it, detailing it, call-outs, sections, elevations, notes, and then all the Colby compliance that has to be programmed into this. When we're talking about bringing in families from manufacturers and getting them on schedules, and then we're going to get into systems eventually, and documenting the systems and scheduling the systems and analyzing the systems, airflow and voltage and pressure and variable air volume and all that good stuff. So speaking of variable air volume, I don't want to talk until I'm blue in the face. Let's stop this one here, and we'll move on as we do. It's 12:03. I gotta make a lunch. I got a few things on my itinerary to do today, but I think that's good for now. Hopefully you enjoyed the video.